Hello everybody. Today's lesson is going to cover classifying polygons. So let's get right down to it. So in your guided notes, you might notice that we have a couple things. First, we have polygons and not polygons. Maybe or maybe not, that is self-explanatory. I want to talk about what makes a polygon and what does not make a polygon. So let's kind of look over these shapes. Now, the polygons that you might notice here in this group, you might notice that they are all closed. You know, there's not a single opening. You know, whereas in this shape, you'll notice there's an opening right there, and it's not closed right there. Another thing that's important is that it's made up entirely of line segments. Line segments have to be straight. Another thing too that a polygon has to have is 3 or more sides. So it's a pretty simple definition there for what makes up a polygon. It's got to be a closed figure, closed shape made up of only line segments, and it's at the fewest, it's going to have 3 sides or more. So the triangle, of course, is the smallest that a polygon can get in terms of the number of sides. It's impossible to have 2 sides and have it not be open. It's always going to have kind of an opening there. So that's going to be impossible. Right, now, what does not make a polygon? Well, the thing that we can kind of just go over all the antonyms here. Already hit upon this. It's not closed. Oh, let me go back up to one of these things. I just thought of this. Polygons have to be in 2 dimensions. And the reason I say that is because I'm looking at this cube right here. So you don't want any 3-dimensional solids right there. You'll notice that there's quite a few where you'll see things that don't look like a line segment. If it curves in any which way, if it's rounded or curved, it doesn't have to be round, but if it's not straight, it's not a line segment. So you'll notice that there's curves, there's openings. Right here, you'll notice that the segments cross. That cannot happen. For this one right here, you'll notice that that's a segment, and that's okay. Some people might look at that and go, that definitely makes it a polygon. But this part right here, the curved part, makes it so it's not a polygon. So you can't just go, well, it's part of it's a line segment and part of it's not, and that's okay. That it has to be completely closed, and all the parts of it have to be made up of segments. You know, right here you'll notice that's a segment, this is a segment, that's a segment, that's a segment, but the only thing that's keeping this from becoming a polygon is that it's open. The definition of what makes a polygon and what does not make a polygon is pretty straightforward. Okay, moving on here, let's talk about regular polygons. A regular polygon is a polygon. Obviously, it's a polygon, but it's a polygon that is, I'm going to get all fancy on you here, but that is equal angular. That means equal angles. And equilateral, which you might only hear that used when you're describing a triangle, like an equilateral triangle, but equilateral literally means equal sides. So a square is an equilateral polygon. It just happens to be an equilateral polygon that's quadrilateral. Basically, all the same sides, and so it has same sides and same angles. You know, 100% of it, not just part of it, not just 99% of it, 100% of it. All the sides are the same length. All the angles are the same measure. And so what makes an irregular polygon is just just take everything about a regular polygon and just negate it and just say, you know, it's everything that's not equal angular, everything that is not equilateral. All right, so moving on to a convex polygon, sometimes it's best, I think sometimes when you define something, it's best just to kind of show it instead of just writing it down. Convex polygons will take on this shape. And one way to kind of prove that is if I were to draw segments. Let's say I wanted to connect this point with any one of these points. Those are called vertices. If I want to connect that vertex with any other vertex in that quadrilateral, would I have to go outside of the polygon? And the answer to that would be no. I can connect that vertex with that vertex. I don't have to go outside. This is already connected. That's already connected. So there's no vertices here that can be connected with a diagonal that has to go outside of the polygon. Whereas with a convex polygon, we draw a convex polygon. Convex polygons look like this. I mean, they can take a ton of different forms. If I were to attempt to connect some vertices here, you'll notice that I can get away with a few. I can connect that one there. I don't go outside of the polygon at all. I can connect those two. I can connect these. That's okay. But where it kind of falls apart is right here. I would not be able to connect those vertices because I'm going outside of the polygon. So that's one way to kind of look at convex versus concave. Now, the way I was taught, and it's the way I think a lot of people prefer to think of it, is that my teacher, of course, when I was learning this, always said, well, a concave polygon, you'll see that it kind of caves in. Some people they'll say, oh yeah, it looks like it caves in, whereas this one, there's no caved in part. So that's one way to think of concave versus convex. And then I'll just spare you the definition there. If I go over the definition, it's just going to make things more complicated. So let's just just go with the picture. Okay, next, let's talk about how to classify all the more common polygons that you guys are going to see in math, and just kind of talk about their names. Okay, so next let's go through and start classifying polygons by the number of sides and giving them the proper name. Okay, so of course this one, and I'm starting in order here with the fewest number of sides, which is 3, and obviously that is called a triangle. Now we can get more descriptive here, but I'm just giving the general name of the polygon. Of course we can call that an equilateral triangle, or maybe if it was shaped differently we can call it isosceles, or we can call it acute or obtuse. There's different ways you can classify that, but in the simplest general way we can just call it a triangle. Same thing with the next one here. Obviously that has 4 sides. It looks like a square. The general name for it is a quadrilateral. Quad meaning 4. So quadrilateral, which is a very generalized description. There's lots of different quadrilaterals. There's a trapezoid. There's parallelograms. That was a terrible parallelogram. There are parallelograms. There are just basic rectangles. There's rhombus. We can have a lot of different quadrilaterals, but like I said, I'm just going over the general description of the polygon. Next one up is going to have 5 sides, and that is called a pentagon, just like the headquarters of our military. That's called the Pentagon, and that has 5 sides. Now, one thing I'm not showing you, but I just want to make a note that you are going to see this. You'll sometimes see hash marks that are marked on the segments themselves, and that is there just to indicate that they're congruent. Sometimes it's not always going to be 1. Sometimes you'll see there's 2 hash marks. And so everywhere there's 2 hash marks, that represents those are congruent. And let me not assume anything. Congruent just means equal. So in geometry, we kind of switch things up a little bit. We don't always want to say equal, because equal can mean a few different things in geometry, so we try to use different terminology. Congruent is sometimes the best way to describe that. All right, so moving up from a pentagon, the next number of sides is going to be 6, and that is called a hexagon. Moving up from that, 7-sided polygon is called a hept, H-E-P-T, heptagon. After that, the stop sign shape, 8 sides, that's called an octagon. 9 sides is called a nonagon. And 10 sides, one way to kind of remember this is that 10 years is called a decade. So 10 sides is called a decagon. And just kind of keep in mind all these, all the, well, at least the first few common polygons that we were classifying here, they're all regular. Every one of these examples was regular. You can see that we haven't really formally talked about angles, but all the angles are the same measure. sometimes you can't always assume that, but you can definitely kind of eyeball those and definitely tell that those are the same. Same thing right here. You can see that these angles are all the same. And every single one of these, like I said, is a regular polygon. But we're just kind of going over all the different names. And really, those are the more common ones. I mean, you might get to 11. What's 11? I think 11 is called a hendecagon. I'm not sure why it's called that. It has nothing to do with a hen. 12 sides is called dodecagon. And so on and so forth. And then I just for kicks, I threw on here, right here, that's 100 sides, and that's called a heptagon. Some people are like, well, you know, who are you fooling here? That definitely looks like a circle, but you're right, it definitely looks like a circle. And I guess you could take my word for it. But these are all right here. If I zoom in on these lengths here, I know I'm zooming, it's getting really pixelated. But these are all line segments. It gives the impression that they're curved, but they are all perfectly straight. And these are all, this is a vertex right there. So that's a line segment. That's a line segment. But there's so many line segments and there's so many sides on a heptagon that it gives the illusion that it's curving and that it's rounded, but it's really not. If you're wondering, there's other sides. I think 1,000 sides is called I'm probably not spelling this right, chileagon. 10,000 is a myriagon. I know a million, and good luck trying to draw that, but 1,000,000 sides is called a megagon. If you want to go to even further, 1 billion sides is called a gigagon. Those are the ones I know off the top of my head, at least. So you got, yeah, that's just for fun. You don't really have to know that. I just wanted to throw that on there just because I always thought that's kind of interesting to talk about. But yeah, you should know these and kind of have these committed to your wealth of information that you know about math and geometry. And then lastly, why don't you go through this right here? You can pause the video at this point. Go through these last few right here. And I want you to classify these. Are they regular or are they irregular? All right. Another thing you can also put in there, is it convex? Is it concave? And then give the proper name. You know, what is the actual name of it? All right, so this is a good point where you can pause the video and just go through these, count the number of sides and try to figure out what it is, and see if your answers match up with mine. Okay, so if you've unpaused the video at this point, this shape right here has 1, 2, 3, 4, 5 sides. So that is definitely a pentagon. Now what it also appears to have, it appears to have all these equal angles, and all the sides also appear to be equal. So that is definitely regular. So that is going to be a regular pentagon. Oh, and we didn't indicate whether it was convex or concave. And that is definitely convex. There's no part of it that is caved in any way. Next one here, you count the sides, and you might notice, oh, it's got the same number of sides. The only difference here between the first one and the second one is that this is not regular. So that's irregular, but it's still a pentagon. And it doesn't matter, you know, as long as it has 5 sides, 1, 2, 3, 4, 5. If I told somebody to draw a pentagon, that is probably not the first thing somebody would draw. But that, as long as it has 5 sides, it's a pentagon. If I said draw a regular pentagon, yeah, you might want to draw something that looks like that. But if I said just draw any old pentagon, you can really just, as long as it has 5 sides, you're good. Now the pentagon I drew right here is concave. This one is definitely convex, just like the first one. This next one here, we're going to count the number of sides. You got 1, 2, 3, 4, 5, and it definitely looks like the sides are all equal. 6, 7, 8, 9, and 10. And so that is definitely a regular decagon. And that again, just like the first couple, is convex. There's no part of that that's caved in. This one right here, you don't really need to number them, but I'm going to do that. You got 3 sides, and that is a regular triangle. I know most people would just say, well, that's an equilateral triangle, but all we have to do is classify it as regular or irregular. So that is a regular triangle. And there's no way around it. All triangles are convex. They're definitely convex. The next example here, count the number of sides. All right, we have 1, we have 2, and I'm noticing that they're not all the same length, nor do the angles look the same. 3, 4, 5, 6, 7, 8, 9. So that has 9 sides. So that not all the sides are the same. That's irregular nonagon. And this is our first example that is concave. You'll notice like right here, kind of caves in. Also right here, it caves in. Okay, the next shape right here, you'll notice it has 4 sides. And you might also notice that not all the sides are the same length. So you've got, right there looks like a right angle. You got this, probably the shortest side. This is probably the second shortest side. And this right here is the longest. And it doesn't matter. If you can identify that all the sides are different, you have it. It's an irregular quadrilateral. Some people might also describe that as a trapezoid, which is also true. But again, we're not getting that specific yet. And that is convex. Counting the sides on this one, we've got 1, 2, 3, 4, 5, 6, 7, 8. And you can definitely eyeball this, and you can tell that the side lengths are not the same, nor are the angles the same. So that is an irregular octagon. And I would say that this one is convex. And the last one, we count the number of sides. We got 1, 2, 3, 4. So that is definitely quadrilateral. And that quadrilateral does not have equal sides. And this one is concave. It kind of goes in. You can definitely tell right here. Goes in. If I want to get really technical here, the reason that it's concave is because if I were to try to connect this point with this point, I would have to go outside the polygon. You know, there's a few points in here where you can connect them, and you're like, well, you can connect those without going outside. But if there's any part of it that when you try to connect the vertices and you have to go outside of the shape, that definitely makes it concave. That does it for your lesson here. Make sure you guys go ahead and do the IXL assignment that accompanies this lesson. Again, if you guys are having trouble logging in, let me know. It seems like some of you, I think, were emailing me and telling me that you guys were getting messages that said you were not registered. I think that's because you didn't sign in with the username I gave you. So make sure you use that username. If you're not getting in, let me know and I'll try and I'll see what's going on and I can get all that settled for you. Otherwise, that's it. Everyone have a great day. Be safe and take it easy.